What's going on, you vaping food? This is the vaping fish again, and I felt the need to show you something. And I think I should have touched this before, or maybe I did, but very briefly. Let me just rip some shit here because I'm testing an RDA, and I want to see how it's vaping. I've been vaping since yesterday, but I'm just testing. I'm also testing some wicking, some cotton that I got from an eBay store. It's a new wicking cotton, supposedly organic. So I've been testing it for flavor and also dry hits. Interesting. Um, all right, guys. The reason I'm making this video is to show you circuits on and connections on your mods, on your box mods, your either regulated or unregulated. First, let me just give it a tug. Yeah, I stick 100 watt. Yeah, I got 0.36 ohms on a dual coil. They're macro skinnies. Macro skinnies. I think they're only like 6 turns on each. Um, I don't remember. I think it's 24. Yeah, 24. Uh, I didn't want to get the um, the RDA too hot, so I chose to have them smaller, less skinnier, not too wide, but with a larger diameter. Full open, but with a 510, so good flavor. I'm very much liking that RDA, but it's a bitch to build. The post, I don't like them that much, but I'll get to it later. Let's talk about circuits. These are my drawings, and try to explain something to you, and it's hard to explain with words. So your mods are connected either on a positive, on a parallel, or a series connection. Let's start with the series, and what does it do for you? Series. This is a diagram for series, basic diagram for series. It doesn't mean it's exactly like that, but for example, uh, you know, for illustration purposes, that's what it is. You got your coil right here, so your negative, that will be your threading on your RDA, and then your positive will be your positive pin, right? All right. And this is your batteries, your positive and negative. And that's how you connect them on series. You're gonna put, positive on top, and then negative, and then positive, and then the negative. So it's positive, negative, positive, negative. That's a series connection. It doesn't have to be one on top of each other. You can put them side by side, but it's gonna be inverted. So you're gonna have your positive, negative, and then your negative, and then your positive. In a little, battery sled. So if you put them inside a sled, the most of the time, if one positive to the bottom, one positive to the top, that's a series. If you have both positives to the top, that's a parallel. Of course, they can be wired through the back any fucking way you want it. So, yeah, but most of the time. So this is a series, and what does it do for you? It gives you double the voltage. So let's say you have a battery that is discharging 4.2 volts, max, and then a nominal discharge of volts. Your voltage is going to be reading at 3.6 after the drop, after all your loads and stuff in there. So you got two batteries. So you're going to be, instead of 3.7 or 3.6, you're going to be doing more. You're going to be doing 7.4, 7.4 volts total. So what does that do? You increase the voltage, you got more power, it's heavier, like hit, boom, right? So, a lot of people like series because of that. My IPv4S is connected in series. But the batteries don't discharge at the same rate. Even though they're one on top of each other, they do not discharge at the same rate. One discharges faster than the other. So that's another thing you have to look at. So you have your switch here, your negative line, your positive line, your coils, and your batteries. So when you press the switch, you drop the switch, you close it, closes the circuit, closes the circle, energy starts flowing, and makes that coil glow. Why? Because it's very thin, the wire, so it gets hot and it starts glowing. So, and it evaporates your vapor, your e-liquid. So once you close that switch, you complete the circuit, and that's just glowing. What's a short? Well, let's say you have a piece of the threading. Let's say you have your positive pin, touching your something negative on the, on the mod. So that means something will be like a line from here to here. And if you energize it, close the circuit, when it throws the energy, you're gonna have energy going here on that short and also to your coil. But depending on the resistance, probably your short is not gonna have a lot of resistance there because it's a direct short. So it probably won't even get a chance to glow. It will probably pop your battery first or short your battery first. So that's your series, double your voltage. That's what it does for you. You have parallel. Parallel, it doubles your MOS or your milliamps an hour. So you have 2500. On this one, it just doubles your voltage. The series just doubles the voltage. You still stay with the same MOS or milliamps an hour. It's a 2500 milliamp. That's even if you have two batteries, you're still gonna have 2500 milliamps, of charge. Your voltage double, but your amperage also stays the same. So let's say they're rated 20 amps each battery. You're still gonna have 20 amps on your circuit. That's it. That's your limitation, 20 amps. So the only thing that does on series, it will double your voltage. Now on parallel, two things change. Even though there's two batteries, both facing the same way, two positives up and negatives down, or both batteries, facing the same way. This is your diagram. This is your switch right here. This is your negative line. This is your positive line. And as you can see, the battery is connected, the positive leg to the positive line and your negative leg to the negative line. And also the other battery, positive to your positive line, negative to the negative line. You can add more batteries, 3, 4, 5, 6. Doesn't really matter. You can add as many as you want. I mean, it's a circuit. But the thing is, with parallels, they both work the same. They work together. They share the load. So they discharge at the same rate, and what it does, it will double your battery life. If you have 2500 on each battery, you're going to get close to 5000 milliamps of use on your batteries. Not exact, but more battery life. It will last you more than the series. Your amperage, let's say they're rated 20 amps each battery. Instead of having 20 amps, you're going to have a good, rule of thumb will be 1.5 times your amperage. So you have 20 amps, you won't have 40, but 30 amps. 20. So let's say 1.5 times, on the amperage. I will go by that. I won't go over that. And then your voltage remains the same. You're still throwing the 3.7 volts each battery is throwing. That's all that's getting there. You won't increase your voltage. It stays the same. Now, let's say this battery for some reason goes out. This battery will still work. So because you still have a complete circuit. Once that switch closes, you're energizing the whole thing. And let's say this battery goes out for some reason, that battery will still work. It will do all the load, but it will still work. But if this one shorts out, it's not a pretty sight, so it's still dangerous. So the thing is, when it's in parallel, you're sharing the load. You're not overworking the battery. You have more leeway on your amperage, and so I prefer parallel. It doesn't mean it's the best one. My preference is parallel. So this is a basic circuit. These are schematics that more or less I drew on a piece of paper, so I can show you an illustration of what it is. So parallels doubles your charge, and it throws your amperage to 1.5 times. Voltage is the same. On series, you double your voltage. but your battery life stays the same and your amperage stays the same. So depends what you want, depends what you're looking for. A good example for series and parallel circuits are Christmas lights. Let's say you have, your Christmas lights, you put it outside your house and shit. You turn it on, and then one little light starts like flashing, and boom, goes out, and then, a strand of fucking 10 lights go out in front of it. That's connected in series. One goes out, the rest of the fucking circuit goes to shit. Um, let's say you have another connection, another little strip of lights, and you connect it, and only one light goes out, and the rest keep on blinking. That's a parallel connection. So when you have a parallel, each load or each you know each circuit or whatever has its own. Each load has its own circuit. Each load has its own circuit. So that's the reason why on certain mods, for example, this one, the iStick 100, you have two batteries in parallel. If I take out one battery, the shit will work still. Running on one battery, so you won't have 1.5 times the amperage, and you won't have double the milliamps an hour, but you still have a working mod when you have a parallel. It happens because when you put the first battery on this shit, it starts up, it lights up and it starts working. You put the second battery, well, you have a shared load on your coil. So that's just a good example of how things work. The thing is, you have to make your own decision on what is it that you're looking for. You're looking for more voltage, or you're looking for more battery life and more leeway on your amperage. So series, one goes out, everything goes to shit. Parallel, one can still carry a load. So that's it. Hope this illustration is shitty, but hope they helped. You know, hope you can understand what it is that you're looking for. It's always, if you're gonna be messing with coils and shit like that, it's good to get a meter, a multimeter, that does read resistance and voltage. Of course, if you're gonna be using batteries, you have to use the B with a flat line. That's your DC direct current, rating, and then your V with a little, like, just really type of curvy thingy. That's your AC. That's your AC voltage, your alternating current voltage. And then you have your ohm sign, your omega ohm sign type of deal. That's your resistance dial on your meter, and that will tell you how much resistance you have from one point to the other. So when you turn on that meter, you put these together. It should give you point. Well, I mean, it won't give you points. 0.1, 0.000. It usually will give you. We're gonna be jumping from 0.1, 0.2, 0.001, 0.002, depending on the dial you have it on. But that's your meter. You can, with the least you can go. Let's say you have an RDA. You have your deck there, and you have it connected to a mod. Let's say the batteries are out, and there's no coils on your RDA. Can you check it? Yes, you can check it. You put one lead on. You're gonna be using resistance, for example. You put one lead to your negative post, one of your negative posts, and you can put it from post to post, negative to negative, and it should read some resistance. You can put it from your negative post to the body of your mod, and it should read some kind of resistance. Let's say you put it from your negative post of, one lead on the negative post, one lead on the positive post. It shouldn't read shit because there's no coil there. If it reads, then you have a shorted RDA. And you can change when you fire it up. You can put, the both leads, just hold them and fire it up. It'll tell you your discharge voltage on it. And always use DC when using mods, because we don't use alternating current on mods. And if you're doing that, shit, let me know. So thank you guys for watching, and I'll see you soon again. Bye bye.